Welcome, Algebra 2s, to our video on rational exponents. So I know that this combines two of your favorite things, fractions and exponents, in one concept, but let's just go ahead and jump right in and get started with it. Okay, if the nth root of a is a real number, and m is an integer, and m over n is in lowest terms, so there's three stipulations there. Nth root of a is a real number, m is an integer, and m over n is in lowest terms. Then a to the 1 over n power is the same thing as the nth root of a. A to the 1 over n is the nth root of a. Let's do an example with that so that we can see what's going on. Like a to the 1/2 power, that's the square root of a. Or a to the 1/3 power, that's the cube root of a. And then we have a to the m over n, so the fraction m over n. And there's two ways to do this. The top part is the exponent, the bottom part is the index. So you can do it with the index on the radical and the exponent inside, or you could do it with the index on the radical and the exponent on the whole thing. And it works both ways. So for example, a to the 2/3 power would be the cube root of a squared, or it could also be the cube root of a, the quantity, squared. Both of those are the same, and later in the video we're going to see how we can use one or the other to make a problem easier based on the individual problem. Lots of examples in this video. Let's start with these three. So 64 to the 1/2, what would that be? Well, that would be the square root, so 2 index of 64, which is just equal to 8. And you could do 64 to the 1/2 power in your calculator. You could do 64 to the 1/2 power in your calculator and it will work. All right, equal sign forgotten. All right, next one. 11 to the 1/2, square root of 11, times 11 to the 1/2, which is again square root of 11. Root 11 times root 11 is 11, so that one's easy too. Again, you can do that in your calculator. All right, this one's a little different, a little bit more work. So 3 to the 1/2, that's the square root of 3, times 12 to the 1/2 is the square root of 12. Well, let's use the product property and put them back together, because that makes this a much easier problem. 3 times 12 is 36, square root of 36 is 6. Awesome. All right, keep on keeping on. All right, so a couple examples, moving on to just seeing how this relates to what we know about exponents already. The properties of exponents also apply when you're dealing with rational exponents, just like they applied with integral or integer exponents. All right, let's do a couple examples. If I have 8 to the 1/3 power, whoa, hey, let's fix that. And let's lock that in place real quick. 8 to the 1/3 power times 8 to the 2/3 power. Just like I could over here, I could add those exponents, I can add them here. 1/3 plus 2/3, which is 1, and that's 8 to the 1st, or just 8. Same thing with power of a power. We actually just saw it where I used it on another problem. But if I have 5 to the 1/2 power and I raise that to the 4th, 4 times a half would be 2. So it's 5 squared, or 25. Okay, the power of a product. If I have 4 times 5 and I'm raising that to the 1/2 power, that is like saying 4 to the 1/2 times 5 to the 1/2. Or the square root of 4 and the square root of 5. Now I can take the square root of 4, that's 2, but I can't take the square root of 5, so that's 2 root 5, or 2 times 5 to the 1/2 power. So those laws of exponents still apply, but we still have 3 more. Let's look at those. Our negative exponent rule, and so on. So negative exponent, we actually just used this, but if I'm being complete here, how about 9 to the negative 1/2 power? Well, that would be 1 over 9 to the positive 1/2. Because it's the same rule, 1 over. And the 1/2 power of 9 would be the square root of 9, which we know as 3. So that'd be 1/3. And again, you can put that in your calculator, 9 to the negative 1/2 power, and it should come out 1/3. Probably gives you 0.3 repeating, but you know what I mean. How about 7 to the 2/3 over 7 to the 1/3? Well, we can keep the base and subtract the exponents. 2/3 minus 1/3 is 1/3, and that would be the cube root of 7. And the last one, power of a quotient could be the quotient of two powers. So how about 5 over 27, and we're going to raise it to the 1/3 power? 1/3 power? Yeah, let's do that. All right, cube root of 5 over the cube root of 27. Well, I can't take the cube root of 5. So we're going to go back to leaving that 5 to the 1/3. Cube root of 27, though, that I can do. That's 3. So we'd say 5 to the 1/3 over 3. So all our properties of exponents still apply. Onward with more examples. Okay, let's see how we can simplify these expressions. Okay, so to start with, we're going to go ahead and rewrite this in exponential form. So it's going to be 3 to the 1/2 times 3 to the 1/4. All right, well, we can add our exponents together. So 1/2 plus 3/4. 1/2 plus, excuse me, 1/2 and 1/4, which is 3/4. So now you see where my 3/4 screw up with my mouth there came from. So 3 to the 3/4, so 3 to the 3rd, and then the 4th root of that, so the 4th root of 27. I always run out of space on stuff like this. Excellent. Next one. Square root of x to the 3rd would be x to the 3/2. So remember, square root, 2 index is a denominator of 2 for the exponent. Exponent is the top part. And then this one would be x to the 2/3. Now we need to subtract. 3/2 minus 2/3. Well, that would be the same thing as saying 9/6 minus 4/6, which would give me 5/6. So I'm going to have x to the, let's go back to the color, x to the 5/6 power, or the 6th root of x to the 5th. How about this one? Square root of x is 7 to the 1/2 times 7 to the 1/3. Well, 1/2 is 3/6. 1/3 is 2/6. So all together, we have 7 to the 5/6. Now that's pretty unpleasant to put back into exponential form because I don't know what 7 to the 5th power is off the top of my head. So I'm going to cheat and use a calculator. Hold on. Ooh. All right. So 7 to the 5th power was 16,807. Oof, big number. 2 more slides, guys. Let's power through. Okay, here's where those 2 ways to look at it are actually going to come in really handy here. So we're going to do each of these problems in 2 ways. All right, 16 to the negative 2/5, negative 2, or negative 2/5, negative 2.5 is negative 2.5, which is negative 5/2. So remember, I can look at this 2 ways. Okay, we'll do one this way, and we'll do one this way. I could do, of course, it's got to be 1 over 16 to the positive 5/2. But then at that point, I can make it 1 over the square root of 16 and then to the 5th power, or I can make it the 5th power of 16 and then the square root of that. Well, which one of those 2 looks easier to you? I don't know what 16 to the 5th power is, so I don't think I want to use that one. I think I want to use this top one. I know the square root of 16, that's 4. That's easy, so 1 over 4 to the 5th power. Now that's much more doable than 16 to the 5th power. I know we have a calculator, we can use a calculator, but that's not really my point. It was more the point of making sure we understand how we can do the math. And you always want it to be easier. I'd rather do it without the calculator than with the calculator. And I don't want you just punching buttons because you're not going to be able to do that for everything. All right, well, anyway, 4 to the 5th power comes out to be 1,024. So this is 1 over 1,024. Let's do the same thing here. Let's do 2 methods. If you think you know how to do them on your own, try it and then come back to the video. So it's either going to be negative 32, and we're going to have that to the 4th power, and then the 5th root of that, or it's going to be, let's put that parentheses around that, negative 32 in the 5th root, and then that raised to the 4th power. Which one do you think is going to be easier? Again, I go for the one that has smaller numbers, kinda, involved. Even though the value is the same, I don't want to find 32 to the 4th. But I can find the 5th root of negative 32. That's negative 2. Negative 2 to the 4th power would be negative 2 times negative 2, which is 4, times negative 2, which is negative 8, times negative 2, which is positive 16. So 2 ways to look at those problems, and you should be able to do that on your own when you're practicing in class. Okay, these are the last 2, I promise. They are also a tad more complicated than the other ones. So let's jump right in, and again, if you want to try it on your own first, I totally get it. We're going to split this all the way up and make sure that every factor inside the parentheses gets that exponent of 2/3. Kind of like the distributive property. Try not to call it distributing, though, because it isn't really. X to the 2/3 is next. And then the square root. No, you know what? Let's not make that a square root right there. Let's go ahead and actually switch that one to an exponent too. So xy to the 1/2. Oop. Sorry, editing jump. Xy to the 1/2, and then that raised to the 2/3, which is easier than you think right there. Think about how you multiply fractions. All right, negative 8 to the 2/3. So that's the cube root of negative 8. And then squared. So we'll come back to that in a minute. You probably already got that. This one is going to be the cube root of x squared. We'll go ahead and put the x squared on the inside. This one is going to be, now let's look at these exponents. Remember, power of a power right here, we're going to multiply. Power of a power, multiply. And the 2's are going to cancel and give you a 1/3. So this is going to be the cube root of xy. Cube root of xy. Let's rewrite it again with numbers and with just exponents. So that gives you some perspective on what's actually happening there. Now, this one is negative, let's see, negative 8, the cube root of negative 8 is negative 2. And then we're going to square that, so we're going to end up with a 4 for that one. Times x to the 2/3 times x to the 1/3, y to the 1/3. Of course, I tried to write a 4, though. Pretend those all look like 3's. Okay, so negative 2 to the 2nd power is 4. X to the 2/3 times x to the 1/3, if I add those exponents, I get a 1. So that's x to the 1st. The cube root, or the y to the 1/3 power would be the cube root of y. And that's going to be our final answer for that problem. Whew, exhausting. Next one. All right, so let's apply all the exponents. I'll use red for this one. 16 to the negative 3/4 power times y to the negative 8 to the negative 3/4 power. 16 to the negative 3/4 power, well, that's going to be the same thing as saying, let's see here, 16 is 2 to the 4th. And that's one way to deal with problems like this, and you're going to see why I did that in just 1 second. If I'm simplifying this, it's power of a power, and we multiply the exponents, so the 4's would cancel. That's 4 over 1. That's a 4 in the denominator. The 4's would cancel. So that's 2 to the negative 3. Here, same idea. Negative 8 times negative 3/4 is positive 6. So this one turned out way easier than we thought. We're going to keep the y to the 6th in the numerator, but we got to drop down that 2 to the negative 3, become 2 to the positive 3 in the denominator, which is 8. So that's your final answer for that one. I know they're rough looking, but we'll get the hang of it in class together. All right, guys. See you in class.